Hello and welcome guys to yet another solution. This is one of those DI questions where you truly need to own the data set and you really need to keep your working very clean so that you are able to reach at an answer pretty confidently and pretty easily. So what do we have? When fully burned, natural gas produces 1000 BTU of heat per cubic feet of fuel. Okay, so we have natural gas and what do we have when we say burn? How much do we burn? 1 cubic foot, okay, of fuel. We get energy of 1000 BTU, okay, 1000 BTU, and propane produces 2500. Okay, we have natural gas, we have propane, and it is 2500 BTU. Okay, makes sense. For a furnace in which either natural gas or propane may be burned as a fuel, the efficiency of a given fuel is usable heat energy produced. So if we burn, ideally we should be getting this much of heat energy, like in an ideal world. But in a real world we would be getting a bit less, and that is the efficiency that we would be talking about. Okay, this is the efficiency, is the usable heat, like only the usable heat, not the entire heat produced. Okay, when the fuel is burned in the furnace, expressed as a percentage of total heat energy produced when the fuel is burned. Okay, now Kaiser will purchase a furnace whose efficiency with respect to either natural gas or burnt fuel or propane would be 90%. So the efficiency here is 90%. So say if we burn a cubic foot of fuel, the energy produced would be 1000 BTU into 90%, or here it would be 25 BTU into 90%. Okay, noted. In the table, select for natural gas cost per cubic foot and for propane cost per cubic foot for the values that are jointly consistent with the information. Okay, so say for example, let us define the rate for 1 cubic foot. Say this is X and this is Y. Okay, now what do we need in the table? Okay, natural gas cost per cubic foot, propane cost per cubic foot. So this is X and this is Y, that are jointly consistent with the information given, for which the fuel cost per BTU of usable heat energy produced by the furnace would be approximately the same for each fuel burned alone. Okay, so basically say this is X dollars, right? In X dollar we are producing this much of heat energy. So for 1 BTU of heat energy through natural gas, we would be needing X divided by 1000 BTU into 90%, right? So this would be the fuel cost per BTU. Okay, and we need to find the value of our X and Y for which this becomes same for both. So basically our equation is nothing but X into 1000 BTU, X divided by 90%, which should be equal to Y divided by 2500 BTU, and again here 90%. So as you could see, we could easily eliminate 90% here. And if you see the equation, this is our equation ultimately, and if you simplify it a bit, what it comes out to be is Y by X is equal to 2.5, which also implies that Y is 2.5 times X. Now why is this important? Because we would be using this equation to solve our question. What we would do is think of each of the values as X. Say if this is X, what would be Y? 2.5 times this, right? So 35 twice is 70, and some value greater than 70 but less than 70 plus 35, that is 95. So a value between 70 and 95. Is there a value between 70 and 95? So what I'm trying to do basically, you can use calculator to do 2.5x of 35, but what I do is say 35 is 1 times, 2 times is 70, 3 times would be 70 plus 35, that is 95. So 2.5 times would lie somewhere here. There should be a number in the option between 70 and 95 for this to be X and another number to be Y, but doesn't exist, so this cannot be our answer. Say 70 is our X, So 70 is 1 times, twice would be 140, thrice would be 210. There should be a number between these two, 2.5 times. That is basically 140 plus 35, 5, 7, 175. And the option exists. So if this is x, this can be y. You can check for this. If this is x, what is y? You will again not find the option, and this cannot be x because there's no number greater than this to be y. So yeah, these are our answers here. So see, the reason why I have shown the working in such a manner is because that is how you would be doing an exam. This is what I recommend you to do in the exam. Either you can take out calculator and quickly calculate if that is what is your comfort area, or you can do such approximations to see where does that number lie. And this is exactly how I do this in a real exam environment. Hope the solution helps. Thank you.